What if I told you that ninja ghost werewolves were real? Well, they are. Okay, they aren't technically real, but there is something pretty close. In 1930, quantum physicists were studying nuclear decay and found a new subatomic particle. That particle, called a neutrino, was far smaller than any other, at less than 1/1000th the mass of an electron. It also was the most confusing of any particle. To understand why, you need to understand two things. The first is the electromagnetic force. Have you ever stood up and thought, man, I'm glad I'm not falling through the floor? If you have the electromagnetic force to thank. The electromagnetic force affects almost all subatomic particles. It keeps atoms together and prevents them from passing through each other. That is why you can stand without falling through the floor. As your weight pushes the atoms in your feet towards the atoms in the floor, the electromagnetic force pushes back, preventing you from falling through. The same concept prevents you from just walking through walls, unless you're a ghost. That is, a ghost or neutrino. Neutrinos don't interact with the electromagnetic force at all, allowing them to fly through anything they want, even entire stars. Also, since light itself only interacts electromagnetically, neutrinos are literally invisible. But their weirdness doesn't stop there. Neutrinos have the logic-defying and werewolf-like ability to shapeshift because of the bizarre concept of superpositions. A superposition is when one object is in multiple states at once, like how a wave can be in multiple places at once. Subatomic particles are almost always in a superposition, and for once, neutrinos are no exception. When a neutrino is created, it becomes one of three types, or flavors, depending on how it's made: electron, muon, or tau neutrinos. But as the neutrino flies off into space, it takes on new forms depending on its mass. Let's call those forms 1, 2, and 3. Unfortunately, those three forms don't line up with the three flavors. Instead, each flavor is a different superposition of the three forms. What's more, as the neutrino continues through space, its forms and flavors start shifting. With enough time, a neutrino can even morph into a different flavor than the one it started as. The behavior of the neutrino and its forms are similar to two pendulums attached by a spring. When swinging freely, the two pendulums tend towards one of two states. Either the pendulums swing with each other or against each other, sped up by the spring. But what if you push on just one of the pendulums? Think of this state as the superposition of the first two states, where the swinging of the second pendulum is cancelled out. But because the two original states move at different speeds, the third state is unstable, and slowly shifts so that the second pendulum starts moving while the first is still. This is almost exactly what happens to neutrinos as they travel along. An electron neutrino can morph into a muon neutrino and back, the same way the motion of the two pendulums shifts from one to the other. But as interesting and unusual as they are, why do neutrinos matter? Neutrinos are most likely the most abundant particle in the universe, yet we know very little about them. And the little we do know often contradicts our current theories. This means that we still don't know everything about quantum physics. Also, because of their ability to fly through planets and stars without being stopped or affected, neutrinos can hold information about the farthest edges and very beginning of the universe. So these tiny particles hold great secrets about a universe full of ninja ghost werewolves.